Yeah, so we're going to talk about extending Spark ML. So if you've ever wanted to make a custom machine learning pipeline element, that's what we're going to help you do today. Although alternatively, if you're just interested in learning more about Spark ML, understanding how the pipeline interfaces are made, I think is still kind of interesting. I'm Holden. My preferred pronouns are she or her. It's tattooed on my wrist in case you forget. And I'm a principal engineer at IBM's Spark Technology Center here in San Francisco. It's really great because they pay me to work on open source Apache Spark. And we have a lot of other people also working on things related to Spark. And my boss is in the audience, so I will make slightly different IBM jokes than normal. Yeah. You can follow me on Twitter if you want a Canadian's view about living in America right now, which right now is mostly just kind of sadness and a little bit of confusion. The slides from today's talk will go on my slide share, and I've got my GitHub, which has some code related to this and some other things, which are hopefully interesting. And this is like not the part from my employer. And this being San Francisco, hopefully you know other people like me, but just to be clear, like I'm trans, I'm queer, I'm Canadian, I'm here on an H-1B work visa that people are talking about revisiting. And I consider myself a part of the leather community. And just like, we're normal people, right? We write the same shitty Spark jobs that you do. I get the same out-of-memory exceptions. I don't have a magic Java garbage collector from the secret trans hive mind. You know, we're normal software developers. So maybe, you know, be nice to your fellow humans.
Okay, yeah, I'm Seth Hendrickson. Currently, I'm a data scientist at Cloudera. I'm working on machine learning on the Hadoop stack. Before that, I was a machine learning engineer at the IBM Spark Technology Center working with Holden. I spent the last couple of years contributing heavily to Spark's machine learning library, MLlib. You can follow me on Twitter if you enjoy tweets about machine learning or sports. Connect with me on LinkedIn. And if you want to follow some of the ongoing development in the Spark ML world, feel free to check out my GitHub.
Yeah. And this is the mandatory slide from my employer. Thank you, Vijay, for providing this wonderful mandatory slide. We have this picture of a lot of green stuff in our lobby, which indicates that we write really good software. And if you're ever considering buying an IBM support contract, please do. Especially if anyone happens to buy mainframes, buy several mainframes. Vijay has given me a look. That's the end of my IBM-related jokes. But we have a lot of developers here in San Francisco working on Spark and Spark-related things. And if you want to come talk to us, we're always happy to chat about fun open source Spark stuff. And there's a lot of other parts of IBM that are also working on Spark. IBM Research is here, and they're giving a lot of talks. And I think they've got some really cool stuff coming out, too. So it's not just the STC. It's all across IBM. All glory to my employer. Oh, and we have the slide. Because we're in San Francisco, it goes up and to the right. It's not quite hockey stick shaped, so I haven't done a perfect job. But I am trying to make this graph hockey stick shaped for the purposes of keeping our lab running. So I'm hoping you're all nice people. You've laughed at my jokes about IBM. If you were a VJ, you kind of shook your head at my jokes from IBM. So it's okay. If you object to pictures of cats, this is not the talk for you. There are going to be a lot of cats. I'm hoping, since this is Spark Summit, you maybe know some Apache Spark. If this is your introduction to Spark, that's wonderful. We're really happy to have you. This is probably not the best intro to Spark. You might want to check out some of the other YouTube videos after this talk is finished. How many people work in Scala? Okay, awesome. How many people consider themselves Python developers? Okay, that's a really good number of people. So the sad part about this talk is that right now we can only extend Spark ML's pipeline models in Scala. But for the Python people, I still think it's very interesting to see how they're built. So hopefully you don't all leave. But if you choose to, I completely understand. Yeah.
Okay, so I'm just going to go over what the content of the talk is going to look like. First, we'll just take a look at what Spark ML pipelines are, how can we use them, and why they're useful. we'll introduce the concept of estimators and transformers, which are the building blocks of pipelines in Spark. We'll go over how to implement both of those. You'll probably find at some point Spark doesn't have all of the features that you need built in. In that case, we're going to show you how you can implement your own custom code inside of a Spark pipeline so that it integrates with all the other stuff that you're using. We'll talk about some of the tools that will help us do that. And then we'll go over how to actually publish your new Spark model or whatever custom code you've implemented publicly, either on GitHub or Spark packages, so that other people in a similar situation can use that. At the end, I think Holden's going to try to sell you a lot of her new high-performance Spark book. I do recommend this. It's a great book if you want something that's more up-to-date with the Spark world as of Spark 2.0.
Mm-hmm. And Seth does not even receive kickbacks for that statement. So
Not
it's a
yet.
very, oh, okay, we'll negotiate afterwards.
Okay, so the first thing we need to do if we're going to work with the Spark pipeline is to actually get some data into Spark so that we can work with it. So Spark pipelines and Spark ML are built on top of data frames and data sets. So data frames are sort of the de facto distributed collection in Spark as of roughly Spark 1.6. And the data frames are built on top of RDDs. But in between the data frame and the RDD layer is something called the Catalyst Optimizer, which is able to perform various optimizations on your data frame queries or actions so that it compiles that down into RDD jobs that run very quickly. So we're going to read data in, calling the read method on the Spark session. That's going to give us back a data frame reader object. And then with that, we can use the option method to specify various key value options. So an example of this is if you're reading CSV data, you can pass it in a custom delimiter. You'll tell it what type of data that you're going to use via this format method. Current built-in formats include things like CSV, JSON, Parquet, JDBC. But there's a lot of different built-in data sources that you can use. And then you just load that in by passing it a path to look for that data. So this is a simple example. We're just going to read some CSV data. We'll tell it to infer the schema, so basically figure out whether our columns are ints or floats or strings. And then we'll just tell it to look in HDFS for a CSV file. Okay, so now we actually have data that we can work with. It's time to start thinking about how we can use Spark pipelines to create a machine learning workflow. So briefly, I just want to go over what a pipeline is and kind of what is the architecture and the abstractions that we'll use. So Spark pipelines are built on top of this abstraction called a pipeline stage. So a pipeline is composed of several pipeline stages. And right now, we can think of a pipeline stage as something that just takes in data, does some sort of transformation, and produces some sort of output. We're kind of high level right now. We'll drill down and make this more concrete. But for right now, just think of a pipeline as a sequence of pipeline stages. But if you think of a pipeline as being a sequence of pipeline stages, a pipeline can also itself take in data, pass it through all those pipeline stages, and produce some sort of output. So for that reason, a pipeline is also a pipeline stage. So you have this sort of recursive abstraction where a pipeline is itself the same type as the units that make up. So I said that a pipeline stage produces some sort of output. The output that it produces depends on it being one of two subclasses of a pipeline stage, a transformer or an estimator. So a transformer is something that takes in data and does some sort of transformation on that and produces new data or modified data. So an example is if you have a logistic regression model, that transformer might take the logistic regression parameters, use your features column from the input to make predictions and append that to your data frame. The other type is an estimator, which takes in data and produces a transformer. So an estimator is something that takes in data and learns different parameters based off of that data. So an example of this would be the actual logistic regression algorithm where you run gradient descent on your data frame to figure out the optimal coefficients for your logistic regression. You store those in a transformer and output that. So we said a pipeline was a collection of pipeline stages, and we now know that a pipeline stage is either an estimator or a transformer. So a pipeline with at least one estimator has to be fit. It has to learn on the input, the data that's input to it. So because that is capable of taking data in and producing a model out, a pipeline is also an estimator. And the model that it produces is called a pipeline model. And a pipeline model has basically been fit so that all those estimators you originally had in your pipeline are now transformers. And so a pipeline model takes data in, passes it through all the different transformers contained within it, and then produces some sort of composite output data set. So because of that, a pipeline model is also a transformer. So how do we actually go from estimators to transformers? So you have this estimator abstraction, which extends the pipeline stage. And most of the actual work or the logic contained within an estimator happens within the fit method. So that fit method is something you'll have to implement if you're implementing your own. This is where you'd put something like implementing your own custom machine learning. So you take in a data set, you learn from that, and then you usually will create a transformer to pair with your custom estimator that is capable of holding the parameters that you learned from that and then making predictions. So likewise, the transformer contains this transform method. The bulk of the logic within a transformer goes here. In a linear regression, you'd simply take coefficients and compute dot products with all of your feature vectors in your input data set to get predictions and output that data frame. So now I just want to kind of go over what a simple machine learning workflow looks like and how we can incorporate pipeline stages to do something useful. So in this example, we're going to work with a toy data set. It's about students who've applied to a university and whether or not they've been admitted. So we have some information about their GRE and GPA scores, and also about how prestigious the university is that they were applying to. And then we have a label which says whether or not they were admitted. So if you read this in from whatever data source you're using, you'll usually have one column per category, kind of like what's here on the left. We can't work with this directly in Spark ML. We actually need to take all the different feature columns and compress them into a single features column that has a type vector. And that vector just contains all those values. So this is such a common transformation that you have to do inside of Spark that Spark ships with its own vector assembler transformer. So we can just create that and then tell it which columns we want to use as features. And then we take our assembler transform called transform on our original data frame, and we get some new data frame that now has this features column appended to it. So the next thing we need to do is take our label, which is right now is just a list of yes, no strings, and convert that into a label format that Spark ML can work with, which is going to be numeric values that represent class indices. So this is also a very common task inside of Spark, so we can leverage the string indexer. So the string indexer needs to first learn a string to label mapping by making a pass over the data set. So it maps no to zeros and yes to ones. And so because we have to make a pass just to learn that mapping, string indexer is an estimator. So to do this, we first need to fit the estimator to get a model. And then once we have that model, we need to take the same data frame, pass that through our model to get an output data frame, which now contains the features and label columns that we need in order to use this with Spark ML. Okay, so we're finally ready to actually do some machine learning on this. We're going to use, in this case, a decision tree classifier. And a decision tree classifier is also an estimator because we have to make several passes through our data set to build this tree structure. And then we can hold that tree structure in our decision tree classification model. So the first thing we have to do is call fit on that output data frame from our string indexer. We get a model, and then we can call transform on the same data frame to actually get something, a data set that now has our features, our labels, and predictions. So we could even go further and do things like model evaluation using some of the estimators and transformers that are available within Spark, or hyperparameter tuning. But for right now, we can see how we can use a few different pipeline stages to create something like a useful machine learning workflow. So the problem is that we only had 3 of these stages, and it was already way too much work to keep track of all the different data frames being passed through, calling fit on all the estimators, then calling transform on all those transformers. This problem gets a lot worse if you use more than just 3, which is pretty common. So this is what Spark ML pipelines, one of the main things they were made to address. So instead of individually passing our data through each of those stages, we can just create the estimators and the transformers. So create our vector assembler, string indexer, and decision tree, and then just create a pipeline that can hold those stages. So we call this set stages method. We pass in the stages in order that we want them to be applied. Then we can take that pipeline and call fit once on it. That turns all of the estimators in that pipeline into transformers and gives us back a pipeline model. And then with that, we can take our raw data set that we had directly from the data source, call transform on that, and get our predictions. Okay, so we now finally have an ML pipeline. We know what they're used for and why they're useful. Holden is going to walk you through creating your own custom estimators and transformers.
Right. Thank you. So before we jump right in and start making our own custom estimators and transformers, I think it's important to remember that Spark actually ships with quite a lot of options for us. If we're trying to do classification, we have many options. If we want to do a recommendation type problem, okay, we really only have ALS. But before you go ahead and start making your own custom things, you should definitely take a look and see if Spark already does something close enough to what you need it to do. Because, you know, we can screw around for a week, but it's going to be much better if I can just use someone else's code. And it's important to also check out Spark packages. In addition to the models that ship with Spark itself, a lot of other people have made really cool machine learning tools that fit into this pipeline model that work in Spark, but aren't part of Spark itself. And we can use those in our programs as well. But it's entirely possible that whatever special, awesome business logic you have is not well represented inside of Spark in this model. It's also possible you just kind of want to screw around with Spark for like a few weeks and make something cool, in which case, more power to you, and thank you for choosing to screw around with machine learning. And I hope you make something useful and put it on GitHub for all of us to use. And if your boss asks, I will definitely back you up on the fact that it is super important that you make your awesome Fubaz machine learning pipeline element. Just have them do it in email. I'm much more convincing when people don't see me. Yeah, and so there's also a bunch of data prep stages. Honestly, I think the data prep stages are the places where we're most likely to find something missing inside of Spark, where it makes sense for us to make our own data prep or data cleaning stages, because they tend not to be that complicated, and they can give us really big wins of improvements, especially because we can have very domain-specific things inside of our data prep and cleaning. But now begins our adventure, and this is Miffy. Oh, I forgot to introduce Boo. I'm so sorry. This is Boo. She is our other co-presenter. She comes to almost all of my talks. She says hi. Oh, someone says hi back. Yay! Okay, so Boo says hi, and we'll focus on software. Okay, so what does a pipeline stage look like? So one of the things that all of the pipeline stages have to provide is this function called transform schema. And this is maybe a little weird to think of, especially for estimators. But essentially what transform schema says is, for whatever properties I have set on this pipeline stage, once I'm finally fit to the data and I'm in my final pipeline stage, what is my output going to look like? And the reason for this we'll talk about in a little bit. And the other one, which you probably have but you don't have to have, are some parameters for your machine learning tools. Almost certainly you want to let people configure stuff, if only to pass blame over to the user. If I give people a black box and it doesn't work, I really can't blame them for my crappy black box. But if I put 3 knobs on it, I can claim they set the knobs wrong. So I think that's really useful. So a really simple transformer, and this one is very much not something that we should use and should not be confused with the transformer franchise from Hasbro and Tommy. But a simple transformer, we have this sort of boilerplate at the top that we can just ignore. It has to have this UUID, and it has to have a copy function, which, whatever, we can just call default copy. And if that doesn't work, please tell me. I haven't seen this not work for anyone yet. But whatever. But transform schema is this weird piece of bit that we have to do. And it's not that complicated, we just have to remember to do it. And so here we need to verify that the input that we get is reasonable. And this is because the pipeline interface itself is passing around data frames. And data frames are pretty much untyped, right? They contain rows, but we have no idea what is inside of a row. And so because we don't want our machine learning job to fail at hour 8 because we forgot a column name or we spelled a column name wrong, we want to catch those errors earlier, so transform schema is done and called before we actually fit on the cluster, just to sort of make sure that these types are going to line up and what we've asked Spark to do is reasonable. And so here we say, you know, I have some input, I care about happy pandas, and if there's no information about happy pandas, then there's no point in even computing this data. Because if there's no happy pandas, what is the point of life? Yeah. Right, so this is used to verify that things should work, and ideally it means that our jobs won't fail halfway through. In practice, we still have jobs that sometimes fail halfway through, but this does catch a lot of errors, so it's important to do right. And then we have our work, and this is where our exciting business logic goes. And there's a question. Sorry? Oh, so why does it return struct type rather than Boolean? So it returns struct type because downstream from us, the next pipeline stage could be depending on the output from our pipeline stage. So we have to return what the fields are that we've added, essentially. So we can see here that our pipeline stage requires that there's something called happy pandas in the input, but we're definitely also going to provide this thing, which is a count of the number of happy pandas. So if later on we wanted to do some machine learning based on, say, the number of happy pandas in a city, like this would, our downstream consumers would succeed. And if this doesn't succeed, we throw an exception and then everything's sad. But hopefully we don't go down that path. Cool? Rock. Yeah. So this is where exciting business word count logic goes. And this is the, as a licensed big data instructor, I have to put word count in all of my examples, so we count the number of words. I'm really sorry. They threatened to take away my license the last time I didn't put this in. But you can put something cool here. You don't have to do word count. It's okay. And so the thing with word count is, like, we don't have to learn any parameters to do word count, right? We can just do word count on some input data. So we can make a transformer that is word count. But we might want to make it configurable, right? And so in Spark machine learning, we need to use these param interfaces. And we need to use these param interfaces rather than our normal friendly, like, case class constructors, because Spark provides these really cool tools to do parameter search. And I didn't do very well in statistics, so my approach to training a machine learning model normally involves cross-validation and a really big parameter grid. And you want to help people be able to do that. And so the reason why we do this for input column here is, in theory, we might actually have different data sources, right? And I might actually want to know which of these two data sources is giving me better results. And I might not pay for a subscription to whoever the competitor is to IBM Watson's whatever thing. Please buy all of your data from IBM. Yeah, these jokes are better when my boss isn't in the audience. Or at least, I mean, they're exactly the same. Okay. Anyway, so we can do a parameter search across these. But that's not super exciting, right? Like, our machine learning task, we probably want to do a parameter search across other things. And we probably want to do more than just count the number of words, right? We want to learn something cool. So we're gonna go ahead and we're gonna learn something cool. We're gonna make an estimator. And to make an estimator, you probably want to trick your boss into giving you about a month off work to just sort of screw around with it. And that'll be fun. So estimators are pretty much the same as Seth said. They have this fit method, and they give us back a model. And our model is a transformer. So the string index estimator is really easy. Cats love it. We have this fit function, and our fit function here, you know, picks out all of the distinct words and creates a simple string indexer model. And here is how you can actually access the parameters that you let people search. There's this really nice $ syntax. If you ever miss writing Perl code, we brought the $ back. Alternatively, if you feel like writing Java code, you can call get input call and just have that wonderful Java Beans experience. And our friend the transformer is back. So as Seth was saying, normally when we make an estimator, we make a corresponding transformer that takes the parameters that we've learned in our estimator, and this is what we're going to return. So how do we make a train function that isn't just complete crap? The answer to that doesn't really fit inside of a 20-minute talk, unfortunately. And it very much depends on each individual specific algorithm you want to learn. But if you do your things in this format, you can fit in with all of these wonderful existing Spark machine learning tools, and you can have a lot of fun. You're probably going to want to read some papers on the algorithms that you care about. Most likely, you'll want to do some type of iterative approach inside of your training. Seth has some interesting work around pluggable optimizers. Did you keep that up when you left, or is that?
Yeah, it's ongoing.
Cool, so check out Seth's GitHub. There's some interesting pluggable optimizers. And if you have a closed form solution, that's amazing. Go have a party and spend the next 3 weeks just, having fun, and tell your boss on week 4 it's done. I should stop giving this advice while my boss is in the audience. Right. So what else can we do? So we've made a machine learning model. That's kind of cool. We could put it in an ML pipeline, and we can do hyperparameter tuning. Or you can give it to other people, and they can do hyperparameter tuning on their data. You could add a persistence layer. If you've ever said to yourself, I know what Parquet needs. It needs a companion JSON file. That is Spark's machine learning persistence layer. There is a good chance that is not what Parquet needs. So you might want to consider just doing your own persistence options, or picking something like PMML or PFA. You could work on serving. There's an asterisk, but I'm running low on time, so we'll skip the asterisk for today. So you've made your new fancy thing. You publish it on GitHub. Please think of Python users. You can make Python bindings. They're not that bad. If anyone wants help writing Python bindings, I have a separate talk on YouTube about how PySpark works, and that's I think it's good, and even Boo agrees, very much so. There are a whole bunch of different custom estimators and transformers in the wild, XGBoost, Feature Hasher, MXNet. Oh yeah, fancy deep learning. If you're an academic, this is very convenient for getting funding for your next research paper. So there are a lot of other resources. I have an O'Reilly blog post, but I'm going to focus on the one which makes me money, so we'll skip ahead. There's a lot of lovely books. Once again, I'm going to focus on the one which makes me money. So the next book is High Performance Spark. I think it's wonderful. I'm one of the co-authors. You can buy it from O'Reilly today. It does not exist today, but do not let that stop you from giving me your money. Or even better, your employer's money. If you have an expense account, it is the gift of the season. More seriously, it should be finished by mid this month, and I have a book signing with some free copies of it at 3:50 today down at the O'Reilly booth. And it should be awesome. I think it's pretty cool. I have some upcoming talks. If anyone wants an excuse to come hang out in Berlin for Berlin Buzzwords, I think it's really great. And there's some other really cool Spark talks happening there too as well. And I would love to see you all. So I've got 46 seconds left for questions. And we have a question. How convenient. Yeah. Oh. No, so the feature hasher stuff isn't going to be available inside of Spark 2.2 out of the box. One of my coworkers, Nick, is actually working on it, but you can use it. It's in his GitHub, and you can use the jars from it in Spark 2.2. It just won't be available as part of Spark itself. No, you don't have to copy the code. You can just use the jars. I mean, if you want to copy the code, like, go right ahead, but jars are awesome. We have a second question, but I've got 5 seconds. Yes, so Spark data frames are amazing. They're the future. They have like really awesome performance. The one downside is for machine learning, when we want to do iterative algorithms, Spark data frames optimizer tends to get a little bogged down. So often what ends up happening is it makes sense to turn it into RDDs for sort of like our SGD or whatever like core routine we're doing. And then we turn it back into a data frame afterwards. And if you want to talk about the data frame optimizer, there are a lot of lovely people here. And I am also happy to talk about it, but we don't have a lot of time left. So thank you all for coming. I don't want to eat into the next speaker's slot. I've had that happen to me before. But come find me at the O'Reilly booth if you've got questions at 3:50. And there's also free books. So yeah, thank you.